So far what we have learned is we've learned we can solve a system by graphing, we can solve by substitution, and we can solve by elimination. All of those things came out of Algebra 1. Okay? This one is more of an Algebra 2 kind of thing. So we're going to talk about application of matrices and determinants, and specifically we're going to use Cramer's rule to solve a system of equations. We have to figure out this word determinant first before we can solve a system. There is a whole branch of algebra that is based on these matrices. Okay, we're giving you a little tiny taste of it here. Unfortunately, it's not part of our standards, so we don't cover it here. Okay, when I was in high school, they used to cover it, but they don't anymore. Okay, but when you go to college, if you take like a linear algebra class, they'll be doing this stuff. Okay, so let me. That wasn't the key. Grab the key. Looks crazy, doesn't it? Right? Nah. All right, so what we're going to do is talk about a determinant. So basically a determinant is a square of numbers that is either a 2 by 2 or a 3 by 3, okay? The way we deal with the 2 by 2 is slightly different than the way we deal with the 3 by 3, okay? But typically they start with this little bracket and we end up going to the bars. We'll probably only write the bars, okay? Because once you're taking the matrix is this piece. Once you take the determinant, start taking the determinant, we convert it to bars. So we start by multiplying the top left diagonal. So we would multiply together A times D, and then we subtract the bottom up diagonal. So you can write it if you want C times B or B times C, it doesn't matter. Now, if we are going to do a 3 by 3, okay? The first thing we do is we recopy the first two columns. So all I did here was we took this column and rewrote it down. We took this column and rewrote it down. Then we multiplied down the diagonals, okay? And then we multiplied up the diagonals. All right? When on the multiplying down, we add, or I say we keep the sign. You might want to write that down, okay? On the up diagonals, we either subtract or we change the sign. All right, so we're going to try a couple of 2 by 2s and a couple of 3 by 3s just to get used to that, and then we will go ahead and solve some systems. Okay? All right, so we got to find the determinant of the matrix. I'm not worried about it being brackets over the bars. So we're going to multiply down the diagonal. I'm going to write the work out on this one, and probably after this won't write the work. So I would multiply 2 times 2. What operation did we need in there? Subtract, and then we multiply up the diagonal. We go 1 times -3. So what's 2 times 2?
4.
And -1 times -3.
+3.
And my determinant is?
7.
7. It's pretty easy, right?
Yeah.
It better be. All right. I know we want like 2 or 3 of those on the next test, right?
Yeah.
There might be 1.
Oh.
All right. Okay, let's talk about this. I'm not going to write out as much work for this one. I'm supposed to multiply the diagonal. So what am I multiplying together first?
2.
Which gives you?
4.
4. And what operation? Minus. Good. And I multiply up the diagonal. So what am I multiplying together now? 4 times 1, which gives me? 4. And my determinant is? 0. Okay. All right. I would have you do this one on your own, but I know you're going to freak out because there's a fraction in it. Okay. All right. So let's multiply down this diagonal. What do we end up with?
0.
0. And then the up diagonal will be 2 times 3/2. What happens with the 2's?
Cancels.
So it isn't that bad of a fraction. So could I do that without having to write another whole line? What's 0 minus 3? -3. So that's what a 2 by 2 looks like. Okay. All right. With the next one, I'm probably going to use a couple of different colors to keep us straight. So if you want the colored pencils to help keep you straight, that is more than okay. All right. So the first thing I'm going to do, and I probably do this in my regular pencil, so let me go back to, let's do it in black, okay, is I'm going to recopy the first 2 columns. So 2, 4, 3. And you guys, this one here, you need to be very neat about your work. Okay? If you're not neat about your work, you're going to run into trouble. So I'm going to use blue and red. So if you want to use the same colors I do, I'm going to do blue for my down and red for my up. Okay? So I'm going to come down this diagonal and multiply. So what is 2 times 1?
2.
2 times negative 2.
Negative 4.
Notice I'm just going to write the answer right there at the bottom. Okay? All right. Now I'm going to multiply the second diagonal. So we've got negative 1 times 0. 0 times 3. 0. Negative 3 times 4 is?
Negative 12.
Negative 12 times negative 4 is?
48.
And on the bottom, we are going to either add or we are going to keep our sign. So when I write this workout, I would say negative 4 plus 0 plus 48. All right, I'm going to go red for the up diagonal. So I'm starting in this left corner. So what's 3 times 1?
3.
Times negative 3.
8, 9.
Good. Negative 4 times 0?
0.
Times 2?
0.
0. Negative 2 times 4?
8. Negative 8.
Negative 8 times negative 1?
8.
8. On the top, I said you either had to subtract or switch the sign, right? So, what am I going to do to all of these signs?
Switch up.
Change them or switch them. I'm going to flip them. So I'm going to have a positive 9. 0 doesn't matter, does it, right? And then a negative 8. Now we're going to add that up. So negative 4 plus 48 plus 9 minus 8. What are we getting? Do we agree with the 45? Yeah?
Yep.
Okay. What's wrong?
Why is it there like no subtraction in the middle?
Because we distributed it through by switching the sign.
Oh.
We ultimately did the same thing. Okay, so let me go and address that because that's Ivan has a really good question. So in this chart here, they said we're going to subtract the whole thing, right? Couldn't I distribute that negative through? Yeah, by switching the sign, we did the subtraction. Okay? Notice, it's the same operation right here, right? We subtracted the up diagonal. But, again, we either subtract or we change the sign. Okay, switch the sign, change the sign. So here's what I want you to try. I want you to try example 5 on your own. So I'm going to give you about a minute and a half. Start by recopying. Okay? And then see if you can multiply your ups and your downs. let's check it together. So we recopied the first 2 rows. Now I got to multiply down the diagonal. So what did we get on this first diagonal? 240. So I increased the numbers on you, didn't I? All right. And then what did we get down this diagonal? 0. We like it when there's a 0, right? Because it makes it easy. All right. What about down this diagonal? What'd you end up with?
42.
Negative 42. What do I do to the signs on this one? Keep them. So minus 42. Okay, and then I'm going to change to my red. All right, so what did we get up this diagonal? 0. All right, what about up that diagonal?
280.
Just 280? It was negative 280. Okay, and then what about up this diagonal? 8. And then what do we have to do to the signs? Switch them or change them. So minus 0 plus 280 minus 8. What did we end up with for our final answer?
470.
470. Good. All right, so we taught the 3x3s here because eventually we're going to do systems of 3 equations, okay? You can use it to do systems of 3. I'm going to show you Cramer's rule with a 2x2, okay? So I need you to go ahead and fill in the blanks there. System has, oh, this shouldn't be the word no, it should be 1. I don't know why it's no. And then there's a typo in the matrix. I don't know why there's a typo. It should be an F right here. Is that already typed in for you? No? Okay, that should be an F. Let me see if I can make it better. Sadly, that was copied and pasted out of the book's materials. Okay, so we use Cramer's rule when the coefficients are large or involve fractions or decimals, okay? So that one that we hit that was a fraction in the homework, this would have been a good way to deal with it, all right? It also, if we've got big numbers in front of the coefficients, sometimes that's daunting, and it's much easier to just multiply the numbers using diagonals than it is, and put them in our calculator, than it is to try to solve the system and get crazy fractions everywhere, okay? If the denominator is equal to 0, then that means there's no solution to it. All right? So, this is the official rule. It's going to make more sense once we do it. Oh. I'm wrong on this. It's not 1, it is no. Sorry. I didn't read it well. I was looking at my notes from last year. All right. So, if it does not equal 0. No, I was right before. It is 1. I read 0, so sorry, fix it. All right, so we've got to get what we call the coefficient matrix, okay? Do you see how the coefficients in here, we dropped into these 2 columns? That's how we get the coefficient matrix. Then what we do is we put we find the determinant of that coefficient matrix. It goes in the denominator. Notice, I solve for x and y separately. So if the problem is only asking you to solve for x or solve for y, Cramer's rule is a really good way to go. Okay, because it will allow me to isolate that variable really easily. Then what we do is whichever variable we're solving for, we take this equals, whatever it equals, and we replace that into the column. Okay, so we're going to do this really, really slowly together. I gave you all of this skeleton to write into, right? So it's going to hopefully help you understand how to do it. Okay, so I've got it color-coded. It's even animated. All right. So the first thing I'm going to do is I'm going to fill in my denominator. So I'm going to take the x column and the y column and fill those into the denominator. I'm not writing the variables. I'm only writing the numbers. So I'm going to write down my 5, 2 first for the x column. So we'll fill out into both of them. Do it with me. Fill in the x column and both the denominators. Then I'm going to fill in the y column. And if you like the colors, use the colors. I'm not going to use the colors in the second one. Okay? Okay, so here's what I'm going to do next. Whichever variable I'm solving for, I'm going to shove the opposite set of numbers upstairs. So in the first one, I'm shoving the 7, 5 upstairs. Or 7, -5 upstairs. Why? Because that's the way you solve for it. Okay? So whichever one is you're not solving for, it goes upstairs. Okay? So in the other one, I don't know what's going to animate next. What would go upstairs in the other one? 5, 2. Okay? Oh, I dropped my answers in first. So, and then whatever you're solving for, we drop the answers into. So see how I dropped the 13, 13 in?
Yes.
Okay. In the second one, we are solving for the y, so I'm going to shove the x column upstairs and drop the 13, 13 in for the y column. Okay? All right. Now we're going to go ahead and actually solve these guys. I always do the denominator first because if the denominator is 0, then I know I'm done and I'm not going to do all the rest of that work. Okay? So what's 5 times -5?
-25.
And then we subtract what's 7 times 2? 14. Okay, so it's definitely not 0. What's -25 and -14?
-39.
Good. At the same, before I do my numerator, this denominator is going to be exactly the same, isn't it?
Yeah.
I write that denominator down because sometimes my sign will change when I'm doing this and then this gets messed up. Okay, so I'm just going to be safe and write it down right away. Okay, now let's do the numerator determinant. What's 13 times -5?
-65.
Good. Minus, what's 13 times 7?
91.
Good. All right, -65 and -91 is negative what?
156.
Is it 56, 57? I heard both answers.
156.
Okay. What's going to happen with this double negative?
Cancel. Or make positive.
Positive. All right. Does 39 happen to divide 156 nicely?
Maybe.
Check it out. See if it works. You have calculators.
Yeah, 4.
Goes in there 4 times. So my x value is 4. I could write that part of my coordinate. All right. I've already done the denominator, so I just need to do the numerator. So what is 5 times 13 again? 65 minus what's 2 times 13?
26.
Good. So what is 65 minus 26?
39.
And what does that reduce to?
-1.
So instead of doing substitution or elimination, which I would have probably done elimination and we would have had to get some fairly large numbers in there, okay, I can use Cramer's rule. All right, so today you're going to practice Cramer's rule in your homework. What's wrong? This here, this one, 5 times 13, the minus sign in between, that's part of the formula for doing a determinant. Okay, so we always do a minus sign. All right, let's try it again together. Okay, we don't have all the fancy stuff to fill in, we have to write our own this time. Okay, so I've got an x equals, I'm going to change out of red. So x equals and y equals, and I draw my fraction bar. I'm going to start with my denominator determinant. So what is the x column?
9, 3.
9, 3, good. What's the y column?
4, -5.
All right. Which variable am I solving for in this first one? X. So what gets shoved upstairs?
4, 5.
Good. And then what gets put in for the x?
6.
Good. The answer column, right? Okay. In the second one, what variable am I solving for? The y. So what gets shoved upstairs? 9, 3. And what goes in for the y column? Good. All right. What should I calculate first? The denominator, because if it comes out to be 0, do I have to keep going? No, we know that that's no solution. I don't think we're going to hit one that's no solution, but we always try that denominator first. What's 9 times negative 5?
Negative 45.
And then remember, a determinant is always a minus sign in here. That's just the rule. What's 4 times 3? 12. It's definitely not 0. What's negative 45 and negative 12?
Negative 57.
Good. Before I keep going, I'm going to write that denominator down here because it's the same. And that way I don't lose it. All right, let's talk about the numerator now. So what is negative 6 times negative 5? 30. What operation do we do?
Minus.
Good. Negative 21 times 4.
Negative 84.
Good. Double negative is going to go?
Positive.
Positive. Excellent. So what's 30 plus 84?
114.
All right. Try dividing it out. You can use your calculators. What do we end up with? Everybody okay with negative 2?
Yeah.
Good. All right, let's try the y determinant. So what's 9 times negative 21?
Negative
18, 9.
Do we agree with Ivan? 189?
negative 180.
We okay? All right. And then what operation do we do?
Subtraction.
Good. What is 3 times negative 6?
Negative 18.
Good. Double negative is going to go? Positive. All right. So negative 189 plus 18 is what?
Negative 7, 1.
Okay. What happens with this double negative?
Positive.
Positive. All right. Try dividing it out in your calculator.
3.
3. And then can I leave my answer like that?
No.
No, you need to rewrite it as a coordinate negative 2, 3. Just like the others, we can't leave it as an x equals or a y equals. Okay. Apparently I didn't adjust my example numbers. All right, this one should be 8. All right, so I want everybody to take a couple minutes. I want you to try example 8 on your own. All right, so everybody is trying example 8 right now.
Wait.
You can do it.
Our answers are different. Like, ours
Yours is different than mine.
equals like 38.
Let me see. Do you have a different problem? It's possible. I may have thrown a different one in there. 4. Yeah, there's a. Yeah.
We switched the 10 and the 3. Yeah.
It does look like I switched to 10 to 3. Let's go with what you guys have.
Okay, there.
Okay, so go with what you guys have. I'll fix mine. 10, 3. Maybe it comes out to be 0. Check your denominator first. Give you about another 10 seconds or so. Okay, what is the x column? 410. So we write 410 in both of those. All right, what's the y column? Good. All right, and then I'm solving for x, so what gets shoved upstairs? Good, and what goes in the x column? Good. I'm solving for y, what gets shoved upstairs? And what goes in the y column? Okay, so let's try the denominator first. What is 4 times negative 5? Minus, what is 10 times negative 2? Uh-oh, what's my denominator?
0.
It's 0. So do I need to keep going? What's the answer? No solution. So, you guys, this is another option. I had some people throughout the years who don't understand substitution, don't understand elimination, but they can do Cramer's rule. This is a valid way of doing the assignments, okay? So, when it comes time for the test, we'll probably ask you to do it specific ways on certain ones, so you need to know them all, but you get to pick your own on sometimes. All right? We're pretty close to the time, I'm sorry. So apparently I'll still be trying to stamp homework tomorrow. It took a long time to do homework questions, I guess.